far. Mostly it was about text, but now I'm going to talk about frauds which are reflected in structured data. So just very quickly, what is a fraud? Basically, it's an act of deception or an act that uses unfair, illegal or unethical means to benefit yourself. So typically the benefits are in the form of money, goods or services. Frauds are actually very bad for organizations in many different ways. So essentially, not only you lose money or goods, but often you lose goodwill of the people or of your customer. Right? There are many methods which are used in perpetrating frauds in real organizations. I'm not going to go over all of these, but maybe focus on one or two of these kind of methods. But it's an important thing to know that fraud detection in this kind of application involves a lot of expertise which is beyond data science. Okay, so one has to have a little humble attitude when we deal with these kind of frauds, because very little of it is actually under our control, and a lot of courage and a lot of expertise is needed from people who are not necessarily data scientists. So they have, I mean, it's got a long history. A lot of people have been looking at fraud even before computers came. So there is a lot of expertise, legal expertise, investigative expertise, psychological expertise, in understanding the methods of fraud and detection of frauds and prevention. There are some things that look very similar to frauds, but they are not really frauds, like for example, mismanagement or incompetence in making decisions. So you make some decision and your company loses money. If the intention was not to cheat the company, then it really cannot be called as a fraud, and so on. So you have to be a little careful about where you draw the boundary, what is a fraud and what is not a fraud. Okay, some are regular crimes, I mean that's what I'm trying to say, and some are really frauds. I'm going to focus, so there are two types of frauds, essentially what is called as opportunistic fraud. You do it only once, right? So for example, if my car has an accident, I repair it, and I send my claim to the car insurance company, and I actually spent 10,000, but garage owner is my friend, so I ask him to pad it up to 20,000, right? This is not my regular habit, right? I mean, I do it just because I got an opportunity. But that's one kind of fraud. But very often the frauds are organized, right? So they want to have the same kind of fraud again and again, and they want to make money. So there is very organized, very lot of planning is involved, careful execution, lot of so a lot of different complex modus operandi are involved. The kind of frauds that I am interested in are what I call as complex frauds. So complex frauds are essentially, they appear superficially legal. There is nothing wrong with what has happened. I'm going to give you examples of these. And but there is evidence, because now much of the footprint of your activities is captured in some system or the other, somewhere or the other. So you can use data science to detect some of these frauds, but not all. Okay, frauds which are very difficult to detect, for example, are tax evasion, or very common fraud in India is contracts. Right, you're a government babu somewhere, you give a contract. Right? A flyover which costs 200 crores, if the contractor is your friend, you make it 500 crores, he gives you some, nobody is the wiser for it. So these kind of collisions inside contracts is very difficult to detect. And that's one interest I have, and maybe, frauds are so common that now fraud management is actually a separate function in large organizations. There is an entire group of people devoted to detecting frauds, investigating frauds, controlling frauds, and even preventing frauds from occurring. Right? So here is some description. I'm not going to go through this, but you have to be aware that it has now become very widespread. Wherever there is money, you can actually see people trying to get it out of your pocket, right? Frauds happen in all industry segments. They are not related or restricted to any particular one: banking, insurance, stock market, retail, telecom, energy, utilities. Even in horizontal, like accounting, which is there present in all industries, even there. Somebody mentioned Satyam computers in the morning. It's an accounting fraud, right? So frauds, I mentioned that they cause a lot of loss to the organization. Here are some numbers, right? I mean, they are actually old numbers. We don't know what the. So, for example, health insurance industry in America alone in 2006, that's 14 years ago, the estimated loss was $80 billion in 2006. You can imagine now how much that money must be, right? And there are some other types of losses mentioned here, just for your reference. I'm leaving these slides with Kanmasha, so you can take a look at these numbers if you are interested. The point is the fraud caused loss, a serious loss, right? And if you don't check it, you will be on. So what kind of techniques are needed for detection of these different types of frauds, right? So first of all, they have to be fast and efficient techniques, because huge data has to be processed. So data is often noisy with a lot of errors and missing data elements. So you have to have robust algorithms. Very important criterion for fraud detection algorithms is that they don't like false positives, right? You accuse somebody, your algorithm says, oh, this guy is probably a fraudster, and he turns out to be a regular customer. You're going to have a customer who is never going to come back to you if he comes to know that he was accused, right? So they don't like false positives. Also, another reason is that if you say this is some fraud, the investigation, as I said, it's manual and very labor intensive and expertise intensive. It's very slow, so they don't like. Another important thing, which is to be noted, is that most fraud detection techniques in industry are unsupervised. We can't really use labeled data of past fraud methods, right? So it's very important requirement. And there are some others, you can take a look at these. But this focus on unsupervised methods is very important. And it's what distinguishes fraud detection as a machine learning application from other applications. So there are many techniques that one can use, and they have been used for different kinds of fraud detection. This is just a list here for your reference in case you need. There are plenty of books, papers published in for statistical and machine learning techniques, analytics techniques for fraud detection in different areas. So here is just a list, a subset of these books. So please have a look at them if you are interested. Here are some papers, survey papers that review. They are a little bit dated, but still you should get a good idea of the kind of frauds that happen and kind of techniques that people are using. Here are lots of examples in different kinds of domains, what frauds occur in different domains. So here are examples from the automobile insurance domain. I already given an example. So that's called padding. So you spend X amount, but you actually claim X plus some Y amount, right? So that's a very common thing. So if labor cost was, you actually spend only 5,000 rupees repairing, in the labor cost you charge more, and who's going to know what is the right amount, right? And actually how much effort you actually spent. And there are so many others, like faking injuries, for example, or even faking accidents in automobile insurance domain. And there are so many other examples. And they are all very hard to detect. So one thing I would like to also say, which is very important for people who are interested in applications of machine learning to understand. It should not be the case that, oh, I know deep learning, so let me see if deep learning can be used for fraud detection. That's an entirely wrong approach. It has to be top down. you look at, you forget that you are a computer science, statistician, machine learning, data mining, NLP person. No, that's, you have to drop that hat and you have to look at it from an application perspective. You think like a fraudster. Okay, if, how would you go about doing it? And so from there you come to the problem. No, don't be a hammer looking for a nail, I mean, as they say, right? So you have to immerse yourself in the, because you are up against some very clever people, right, who are trying to cheat you. So there are examples in the credit card domain and many other. I'm going to focus on stock market frauds because that's where I've done some work. So in stock market trading and other activities in stock market, there are a lot of frauds that happen. So for example, insider trading, right? Very hideous kind of fraud. That's very common again because people who are in position of trust and authority often betray that trust. And so you are a CEO or somebody of a company, you know your company is going to get a contract, a large contract, and when the news goes out, the share price of your own company will jump. So it's 100 rupees now, it will go 120 rupees in 2 days, right? So what do? You tell your friend, go and buy my company share, 50,000 shares you buy at 100 rupees. In 2 days, I know the price is going to go up. So after 2 days, the price news comes out, the price duly goes up, and your friend sells the shares at the inflated price, and he gives you some, and you get some. Everybody is happy except other investors because you are using information which is not in public domain to make the money, and this is illegal in many. Interestingly, there is actually a lot of debate about some of these things from an ethical perspective. We don't have time to go into this, but economists are actually looking at this in a different perspective. So you should, so I'm going to focus on a particular kind of fraud, what is called as circular trading or price manipulation or wash trade. It is based on, so there are some more accounting frauds example here. So I will skip this because we don't have too much time. So these are some of these examples of accounting frauds. Satyam is here. So I'll skip this part because I'll come back if there is time. So I'm going to focus on one problem, which is in circular trading or price manipulation in stock market. Right. So real fraud. Harshad Mehta and Ketan Parikh both were actually involved in this, and it's a important kind of fraud. It's important because it uses a method which is very common in other kinds of fraud, which is collusion. So it's not like one person just takes time to cheat the company or cheat the stock exchange, right? No, it's like many people get together and cheat. That's an interesting thing, right? And that is a method that is used commonly in many other types of frauds. Like I have example, already given an example in the contracts domain, right? So how do you do collusion in contract domain? A very common thing, it's called the, the method is something like this. It's called phases of the moon, but that's a slightly different way of doing it. But let me give you an example how they do it. So for example, again, let's see there is a flyover to be built in Delhi somewhere. So many people contractors are interested in building. So what do? So they all get together in some 5-star hotel. They say, boss, ये contract तो मुझे चाहिए. A says, I want this contract. So B, C, D, E, the contractor say, okay, fine, you take it. We will, but we want some other contract when we also know 3 more flyovers are coming up. So that time you don't bid. Or so how they do it? A will give a lowest bid, and all others will give a bid which is way higher than A's bid. So A will be naturally the one who will get the contract, right? So that's how they do it. The phases of the moon comes in because in certain months A gets the contract, certain other months B gets the contract, and so on. So there are these kind of things people do. So collusion is a very common method, and So in this kind of price manipulation or circular trading, it's like passing the parcel game, right? So in passing the parcel, what happens is, so A, B, C, D get together, they focus on a particular stock. Right now it's only selling at 20 rupees per share. So they buy a lot of shares of that at 20 rupees. Then A starts selling some shares to B, B to C, C to D, all at it. So A to B will sell at 21 rupees, B to C will sell at 22 rupees, and so on. They just keep trading among themselves. Nobody is interested in that stock. Only these people are buying and selling. And the price is increasing, and sooner or later people start taking notice, saying that, oh, something may be happening in this company, price is going up. So they also join the bandwagon, the price goes up. So at some point in time, these ABCD people dump their shares in the market. We have made cool money because, and the price comes back to its original level because there is no real reason for the price rise, right? So this is illegal again. How do you detect this? That is the question, right? And there are some things which I have given, like under what laws this is illegal and so on. As I said, collision has been studied in many other domains in options, for example. I gave you an example, right? The bids for government contracts and procurement. It's very common there, extremely common, and very hard to detect, right? Because the people who should be looking after the welfare and the care of the government money are actually involved. So it's very difficult to. So this is based on my old paper, actually not any papers on, but the methods, as I said, are still common, and I'm doing some work which is still continuation of this. So this is actually an example. This is one of the Ketan Parikh actual cases. So the price started at some level, 366 rupees, and reached 390 rupees in very quick time, 7 minutes or something, and then they dumped the shares, and that's how he was caught actually. It's a difficult problem because, first of all, each individual transaction, that's what I was trying to tell you, that A sells to B some shares, that's perfectly legal, nothing illegal about it, right? It's only when you start looking at how these shares are being flowing, how they're flowing across the investors or people, then you start seeing some patterns. That's how so you, of course, there are no labeled examples of this. So stock market people didn't give us, okay, here are known 5,000 cases of collusion. No, that's not how it was. They said, we are not going to give you any data. You do whatever you can, right? So basically, the way I approached it is that I said, anybody, any group of subset of people who are investing in or buying and selling shares in a particular company should be under focus or under suspicion if they do a lot of trading among themselves as compared to trading to outside the group, right? But of course, we don't know whether 4 people are involved, 5 people are involved, whether anybody is doing this kind of thing, and how much heavy should be considered, like how much internal to external trading should be considered bad, and so on. So it's, of course, a naive approach to examine all subsets is completely infeasible because it's exponential in number of subsets, you know that. So my approach that I proposed was based on mapping the trading database to a graph. So here a snapshot of real data. So in this small example, there are about 50,000 transactions among 178 people, and this is how the data looks: buyer ID, seller ID, volume, and the price at which the share was sold. And so on. So first, what I do is I do a group by query on this, and you get a data for pair of buyer and seller. So for example, 1022 sold to 1002, totally 200 shares in 2 trades. I can add more information, but this is just so this is, you get a 1 record per pair of buyer and seller, right? So you can map it to a graph like this, a directed graph, where the vertices correspond to people who are buying and selling, and the edges correspond to actual transactions. So if there is an age between A and B, that means at least once A has sold some shares to B. And the label on the edge can be anything. I have here shown the total number of shares sold by A to B, right? So this is the kind of graph which I called as a stock flow graph, right? So this is now a graph structure. What do you do with this, right? So what I did was to apply a graph clustering algorithm on this graph. So what does a graph clustering algorithm do? Essentially, it will try to put two nodes together in the same bucket if some condition is satisfied. And I tweak the condition for merging the graphs. I'm going to tell you how I did it. So, so there are many algorithms. So these are actually algorithms from the 70s that I tried. I tried many other algorithms also, not reported in the paper. But I have also my own algorithm. You can read the details in the paper. But I'll tell you the shared NN algorithm, which is a 1973 algorithm. So the moral of the story is that just because in machine learning we are sort of conditioned to say, oh, if it is older than 3 years, it is all my grandfather should have used this, not me, right? But it's not the quite correct attitude, because there were some very smart people long before deep learning came onto the scene. So they have some very clever algorithms. So this is one of those algorithms. So what does this algorithm do essentially? So it takes two parameters k and kt, right? So k is 4 in this example. So what does that do? So for every node you identify 4 of its nearest neighbors. So nearest neighbors in this simple example is basically to those neighbors I have sold maximum shares, top 4 of those. Right? So for example, here 1074 has these 4 neighbors, 1042 has these 4 nearest neighbors. So because k is 4, so we are looking at 4 neighbors. The second parameter is kt. So now you want to decide whether I should merge 1074 and 1042 and put them in the same bucket or not, right? How do you decide? So you have their 4 nearest neighbors list. You see how many are common. So you can see all those blue ones are common. Both lists contain those numbers. So 1035 is there in both lists and so on. So the first condition for merging is satisfied, that they have enough intersection, number of neighbors, common neighbors is greater than or equal to kt. But there is another condition, they should be each other's nearest neighbor. So for example, if you look at the nearest neighbor list of 1074, 1042 should be there as one of the nearest neighbors, one of the 4, but it's not there. So this second condition is not satisfied, so we cannot merge these two. But look at the lower example. 1029 has 4 nearest neighbors, 1037 has 4 nearest neighbors. How many are common? 2 are common, as you can see in blue. But the second condition is also satisfied. If you look at the nearest neighbor list of 1029, 1037 is there at second position. And similarly for 1031, 1029 is also there. So both conditions are satisfied. So you can potentially merge these two nodes and put them into a single node, right? And modify your graph accordingly. Right? So this is how you continue to do this iteratively. You examine all pairs of nodes, see which ones can be merged, merge one pair in each iteration and continue like this. It's completely unsupervised, as you can see, and if you have thought about, or if you are awake when I was explaining this, essentially what are we doing? What is the condition I have used for merging? It is actually